students, welcome to physics class. How do you get up in the morning? Maybe by the sound of the alarm clock, or maybe by the wake up call by your mother, or it may be by the sound from outside, or maybe by the chirping of birds. So somehow our day starts with some sort of sound, isn't it? So when we converse, if there is no sound, can you understand anything when the other person speaks? No, isn't it? So sound plays an important part in our life. So in today's class, we move on to the next lesson or the next form of energy, which is sound. So sound is also a form of energy. In the earlier classes, you have learnt about heat energy and light energy, isn't it? So in this lesson, you are going to deal with the concept of sound. So sound is a form of energy which produces a hearing sensation in our ears. So have you ever thought how sound is produced? Yes, sound is produced when objects vibrate. So how is sound produced? So consider, when I strike for example, a table with a ruler, what happens? We could hear the sound. So when I strike, the particles around the table, it starts vibrating and we hear the sound. The particles vibrate and this vibration will make the neighboring particles to vibrate, and this particle will now make the other neighboring particle to vibrate, and likewise the sound reaches our ears. So how sound is produced? Sound is produced by the vibration of particles. So how is sound produced? Sound is produced by the vibration of particles. Now, propagation of sound. So what do you mean by propagation? Traveling of sound. So propagation of sound. So sound needs a medium to propagate. Sound needs a medium to propagate. Say for example, air, steel, water, etc. But sound cannot travel in vacuum. So in vacuum, sound cannot propagate. So this can be proved by means of a Bell-Jar experiment. So sound needs a medium for propagation. Example, it can travel through air, steel, water, etc. But sound cannot travel in vacuum, which can be proved by Bell-Jar experiment. So in vacuum, sound cannot propagate, which can be proved by the Bell-Jar experiment. Let us recall. So in today's class, we have learnt about the sound energy. A sound is a form of energy which creates a sensation, hearing sensation in our ears. The sound is produced by the vibration of particles or molecules in the object. And sound needs a medium to travel. It can travel in air, steel, water, etc., but it cannot travel in vacuum, which is proved by bell-jar experiment. Then we learned that sound is a wave and it travels in the form of a longitudinal wave which consists of compressions and rarefactions, and sound wave is an example of a longitudinal wave. And sound waves has different characteristics. So first one is the amplitude, which is the maximum displacement of the particle from the undisturbed position. Its unit is meter. The next is the frequency. It is the number of vibrations in 1 second. Its unit is N. Its symbol is N, and its unit is hertz. And human ear is audible for the frequency range of 20 hertz to 20,000 hertz. The next is the time period. It is the time taken for one vibration, and its unit is second. And the relation between frequency and time period is N is equal to 1 by T. Then the wavelength. Wavelength is the minimum distance when the minimum distance between two waves when it repeats. That is the wavelength. Its symbol is lambda and its unit is meter. The next feature is the speed or velocity. It is the distance traveled by the sound in 1 second, and its unit is meter per second. So thank you, students. Now let us see the first characteristics, that is the amplitude. So when a wave passes through a medium, the maximum displacement of the particle in the medium from its original undisturbed position is called as the amplitude. So what is this amplitude? Amplitude is the maximum displacement of the particle in the medium when the wave travels in a medium. So maximum displacement means, so this distance. So this is the amplitude. So this distance is called as the amplitude. So what is amplitude of the sound? Amplitude is the maximum displacement of the particle. Maximum displacement of the particle is represented from the original undisturbed position. Okay, so that is called as the amplitude, and its unit is meter. The unit for amplitude is a meter, and it is represented with the letter A. So this is one of the characteristics of the sound, that is amplitude, which is the maximum displacement by the particle when it travels in a medium. Now, if the displacement is maximum, the sound will be loud. If the displacement is maximum, the sound will be loud, and if the displacement is minimum, the sound is a soft sound. Okay, so maximum displacement of a particle in a medium is called as the amplitude of the sound wave. Its unit is meter, represented by the symbol A. If the amplitude is maximum, the sound will be loud, and if the amplitude is minimum, the sound will be a soft one. The next characteristic is frequency. So frequency is the number of vibrations in 1 second. So what is frequency? Frequency is the number of vibrations in 1 second, and frequency is denoted by the letter N. Okay, frequency is denoted by the letter N, small n, and number of vibrations in 1 second is called the frequency of the sound, which is denoted by the letter N, and its unit is S power -1, or you can write it as hertz, or you can represent it as Hz, which is the short form of hertz. Frequency, the unit of frequency is S power -1 or hertz. Okay, Hz is also hertz. Unit of frequency is hertz. So human ear can hear the frequency of range at 20 hertz to 20,000 hertz. The range of frequency is 20 hertz to 20,000 hertz, and the frequency which is less than 20 hertz is called as infrasonic, and the frequency which is greater than 20,000 hertz is ultrasonic sounds. So below 20 hertz and above 20,000 hertz we cannot hear, but human ear can hear the frequency range of 20 hertz to 20,000 hertz, and less than 20 hertz it is called as infrasonic sound, and greater than 20,000 hertz it is ultrasonic sound. The next feature is the time period. Time period, which is denoted by the letter T, and this is denoted by the letter N. So time period is the time taken for one vibration. So time period is the time taken for one vibration. That is one wave. Okay. So number of vibrations in 1 second is called the frequency, and the time taken for one vibration is called as the time period, and its unit is second. The unit for time period is second. The relation between the time period, and they are related, time period and frequency is they are reciprocal. So N is equal to 1 by T. So this formula will be useful while doing the problems. So time frequency of a sound and time period of a sound are related, that is N is equal to 1 by T, where frequency is the number of vibrations in 1 second and T is the time taken for one vibration. The next characteristic feature is the wavelength. So what is the wavelength? So wavelength is the minimum distance that is traveled when the waves repeat. Okay. So here this is the wavelength. So the distance between the minimum distance between the waves when it is repeated. Okay. Or in other ways we can say this, the distance between two consecutive compressions and two consecutive rarefactions is called as the wavelength. So the minimum distance when the waves repeat is called as the wavelength, or else the distance between two consecutive compressions or two consecutive rarefaction is called as the wavelength. Wavelength is denoted by the letter lambda. This is the symbol for wavelength, lambda, and its unit is meter. Okay. Then the next characteristic feature is this, speed or velocity. So what is speed or velocity? That is the distance travelled by the sound wave in 1 second. Distance travelled in 1 second. So that is the speed or velocity of the sound. Okay. And the speed is, its unit is meter per second. So what is the speed or velocity of the sound? It is the distance travelled by the sound in 1 second. Its unit is meter per second. Okay. So we can prove that the air cannot travel through vacuum by means of the bell jar experiment. So this is the bell jar. So inside the bell jar we have placed an electric bell, and close the bell jar with the rubber cork so that the bell jar should be airtight. And at the bottom you connect the bell jar to a vacuum pump. So if we ring the electric bell, we could hear the sound of the bell. Now, by means of a vacuum pump, you evacuate the bell jar. It means pump the air inside the jar out. Okay, so that is evacuating. When we evacuate the bell jar, you can hear only a feeble sound, and at a particular time we cannot hear the sound of the bell. But the bell will be ringing, we couldn't hear the sound of the bell. So this shows that sound cannot travel in vacuum. So the experiment is the bell jar experiment. So I have said that sound propagates through air, through water, through steel, etc. And how it propagates? In what form? Sound travels in the form of wave. So the first property we have learned that sound needs a medium to propagate, isn't it? So first one is it requires a medium. Sound requires a medium for its propagation. It cannot travel in a vacuum. And next I say that sound is a wave. So how can we say that sound travels in the form of a wave? So as I said earlier, when we strike an object, the particles around the object starts vibrating, and this vibration will be passed on to the next particle to vibrate, and this particle will come to its original position. So there is a minute to and fro motion of the particle. Once it makes the other particle to vibrate and it comes to its original position. So likewise, every particle will make the other particles to vibrate and return to its original position. So there is a to and fro motion of the path of the sound wave. So that is why we say that sound is a wave. So this disturbance in the air or steel or water will travel in the form of a wave and it reaches our ear. So that is why we say that the sound is a wave. Okay, sound travels in the form of wave, and there will be a minute to and fro oscillation of a particle. We cannot see by naked ears, but there with the vibrations can be observed. Okay, there will be a to and fro motion. This to and fro motion makes the sound to move in the form of a wave. And there are two types of waves we have learned already. There is a longitudinal wave and a transverse wave. Sound waves has the property of moving in the form of longitudinal wave. So what is a longitudinal wave? The waves which travels in the form of compressions and rarefactions. Compressions and rarefaction. So longitudinal wave travels in the form of compressions and rarefactions. So what is compression and what is rarefaction? Say for example, if this is a spring, if I pull and push the spring, or if I pull the spring, at some point the turns will be very closer, and at some point the turns will be little apart, and at some point the turns will be very closer, and likewise it goes on. So at some point the turns are closer, at some points they are apart. So the place where the turns are very closer, they are called as the compression, and the point at which the turns are apart are called as the rarefaction. So this is, I am saying, giving as an example, but likewise while waves when travel in the form of longitudinal waves, the particles at some point the particles will be very close, and at some point so the particles will be a little apart. There will be spaces in between the particles. So the region in which the particles are very close is called as compressions, and the region in which the particles are far apart, they are called as the rarefaction. So a longitudinal wave travels in the form of compressions and rarefactions, and the sound wave also has the property of traveling in the form of longitudinal wave, so that we can say that a sound wave is also a longitudinal wave. So now we might have heard a different music from different musical instruments, isn't it? Not every musical instrument will produce the same musical sound, isn't it? So what makes this variation? The sound has different characteristics. So this characteristics makes the sound to produce a different notes. Some may be rhythmical and some may be not. It depends upon the characteristic features of the sound. So what are the characteristics of a sound? So there are 5 characteristics of sound. The first one is amplitude. Amplitude, frequency. The third one is time period. The fourth is the wavelength. And the fifth one is the speed or velocity of the sound. So these are the 5 characteristics of sound. So amplitude, frequency, time period, wavelength, a speed or velocity or speed or velocity. So 5 characteristics: amplitude, frequency, time period, wavelength, speed or velocity. So based on these characteristics, the sound, the nature of the sound varies. It may be, we can maybe classify the sound as a noise, or we maybe consider as a musical note, or it may be pleasant to our ears, or it may be sometimes irritating based on the characteristics of the sound.